7. Okay, so let's take a look at a different type of function now. Let's look at 44. So now we are in a better position to graph a function. At the beginning, we were not. No. They wanted us to rush into graphing, but no, that we were not ready. You understand the difference now, right? Okay, so let's start with the domain of this function. Notice that the table, it's up to you. You can rearrange whatever you want. It's fine. But notice the fact that I have the function in the middle and the derivatives above and below. Can anyone give us the domain of this function?
Negative infinity to infinity.
Right. No restrictions whatsoever. Good. So 0 has to be in the table. So let's first discuss the function. So I will have to find f of 0. Can anyone give us f of 0? How much?
1.
0, yes. It's 0 over 1, which is 0. Very good. So 0 over 1 is 0. And now if I write f of x equals 0 to find the x-intercepts, I will only get the same point. So this is already done. The next step, I need the limits. So I want to determine the limit as x approaches negative infinity from x over x squared plus 1.
Infinity.
Say it again.
Infinity over.
Good, very good. So then limit as x approaches negative infinity. What is the top?
1.
Good. The denominator?
2x.
Good. And now the limit will be? The numerator is 1 and the denominator will be?
2.
1/2.
So the numerator is 1 and the denominator will go where?
Would be 2, right?
X approaches negative infinity. Where does 2x go?
So 0.
Okay. Negative.
Good. So 1 divided by a huge number is 0. And that is a typical situation. Y equals 0 is a horizontal asymptote. So 0 here, 0 here. And when you look at this, you'll say, what is going on? You'll see. Okay, now our next step. So we are done with this so far. I cannot find anything else about the function, the asymptotes or the end behavior, the x and y intercepts. There is nothing else. So now I'm attacking the first derivative. So let's find the first derivative. Can anyone help with the first derivative? The top function prime is?
1.
Good. So then x squared plus 1 minus the top function times the denominator prime, which is? Very good. So then we have x squared minus 2x squared, which is negative x squared plus 1 over x squared plus 1 squared. Yes, we have to run a clean ship, and you have to give me how you factor the numerator. We refuse to work with negative leading coefficients, and they have to come out. But now what we have left in the numerator is x squared minus 1. How do I factor that? That was the first thing we did on January the 20-something.
X plus 1, x minus 1.
Very good. See how important this is? Because now when I set it equal to 0, you will automatically give me the solutions. What are they?
X equals negative 1. X equals 1.
That's it. Negative 1, 0. 1, 0. Okay, let's look at the derivative because now we have to establish the sign. Which piece of all this is a waste of time to plug in numbers in? This will not always work like that, but it happened that in these examples that we chose so far, it did.
X squared plus 1 squared.
Very good. Waste of time to plug in anything there. It's always positive. Good. So now please plug in a number to the left of -1, like -10, then plug in 0, and then plug in 10. You can plug in here or in here. It's up to you. I prefer the factored form, but it's up to you. So plug in -10. Don't forget this symbol. And then plug in 0. 0 is easier here. What is the sign of the top when x is 0?
Positive.
Wait, what are we plugging in where again? Sorry, I think I missed a step.
So we are trying to find the sign of the derivative, and I will not plug anything in the denominator. So you have to plug in the numerator. The numerator will give the sign.
And you're plugging in the values we got.
We have to plug in values to the left of -1 to find the sign here, between -1 and 1 to find the sign here, and between 1 and infinity to find the sign here.
Okay.
So if we plug in -10, what do we get?
Negative.
Of course. And if we plug in 10, what do we get?
Positive.
Negative.
Still negative. Very good. So 10 plus 1, 10 minus 1, this will be positive, but there is a negative. When we plug in -10, we have negative and negative and negative, so that's why we still have negative. At this point, we have to determine this value and this value here. So let's plug in -1 in the function. The top is -1, and the denominator is 2. So -1/2. To plug in 1, 1/2. At this point, I do not wait till the second derivative. I have to make sure that these two work well together. And what I learned from the first derivative is legitimate. Okay, so what does the function do between -infinity and -1?
It decreases.
Is that true?
Yeah.
What does it do between 0 and between -1 and 1?
Increases.
Is that true?
Yes.
What does it do between 1 and infinity?
It decreases.
Is this true? 1/2 down to 0.
Yes.
Good. What type of point is -1, -1/2?
Relative mean.
Very good. Local mean or relative mean. Let me write relative because I guess you're used to relative. What type of point is 1, 1/2?
Relative max.
Relative max. Perfect. And this is the x-intercept. Good. Finished with the first two. Now we have to find the second derivative, which is not pleasant. Not pleasant at all. So here's the first derivative. Negative x squared minus 1 over x squared plus 1 squared. So now the second derivative. Leave the negative outside. Square the denominator. What do we get in the denominator when we square?
To the fourth.
Very good. Awesome. Good. So please differentiate the top.
So
X. Very good. X squared plus 1 squared minus x squared minus 1. And now let's differentiate the denominator.
so x
Square plus 1 to 2 minus 1 multiplied by the inner function prime.
so x.
Very good. We run a clean ship. Please tell me what I pull out from the top. As much as I can.
X
2x.
squared plus 1.
2x, very good. 2x will come out. This 2x and this 2x is out. Very good. What else? You're not going to distribute here. This is insane to do it. Factoring is crucial right now. So then you have said x squared plus 1. What is left from the first term?
X squared plus 1.
Very good. Now, this is out. So I have to distribute 2 in here, keeping in mind there is a negative. So negative 2x squared and then plus.
Plus 2.
Very good. Awesome. Look at this. I can even simplify a little bit. Negative 2x, negative x squared, plus 3. X squared plus 1 to the third. Yes, negative is out. It will take care of that. 2x, x squared minus 3 divided by x squared plus 1 to the third. See how difficult the second derivative becomes?
How did you take out that negative?
It becomes negative x squared minus 3, and then it takes care of this.
Ah, okay.
So finally, I know I have only one more minute. I will not be able to graph it. So when we set the second derivative equal to 0, we get an x equals 0, and from here we get plus or minus the square root of 3. Awful, but it is what it is. So negative the square root of 3 and the square root of 3 and 0 and 0 and 0. Terrible. So now, of course, this is always positive. I'm not going to waste my time with it. But I have to plug in negative 10 in the top and see the sign here. Then I'm going to plug in negative 1. Negative 1, this is negative, this is negative. I'm going to plug in 1. This is negative. And when I plug in 10, this will be positive. And when I plug in negative 10, this will be negative. So it does not hold water. It does hold water. It does not, and it does. And we have to take it from here on